The Baghdad Battery. In the 1930s, German archaeologist Wilhelm Koenig was conducting excavations in a village called Kujut Rabu near Baghdad, Iraq. During the dig, he discovered a strange object buried beneath layers of earth. It was a small clay jar, roughly the size of a modern cup. Inside the jar was a copper cylinder, which held an iron rod. At first glance, it seemed like an ordinary container, but upon closer inspection, it was clear that the object was crafted with remarkable precision. Historians and scientists quickly realized it could be an extraordinary example of ancient technology. When filled with an acidic liquid like vinegar or lemon juice, the combination of copper and iron produced a small but measurable electric current. This discovery surprised many. Electricity was formally discovered in the 18th century, so how could such a device exist so long before? Research suggests that the battery dates back to around 250 BCE, during the Parthian period in Mesopotamia. At that time, the region was a center of trade and knowledge, connecting cultures from the Mediterranean to the Indian subcontinent. Who built this device, and what was its exact purpose? That remains unknown. Some believe it may have been used for electroplating metals. Others think it had religious significance, and some suggest it was used for medical or magical practices. These clay jars are still fragile but intact, and they are preserved in museums in Baghdad and Berlin. Archimedes Death Ray. In 212 BCE, the city of Syracuse in Sicily came under attack by the Roman army. The responsibility of defending the city was given to the famous Greek mathematician, engineer, and inventor Archimedes. He was not only skilled in mathematics, but also brilliant at designing mechanical devices. According to historical writings by Lucian and Galen, Archimedes used a device that could set enemy ships on fire. This device is known as the Death Ray. It consisted of a series of polished bronze mirrors that focused sunlight onto a single point. The mirrors were arranged in such a way that the concentrated solar rays could ignite wooden ships. During the siege, some witnesses reported seeing smoke and flames rising from Roman vessels. However, modern researchers question how effective this method truly was. In the 20th and 21st century, scientists attempted to recreate this technique. Some small-scale experiments successfully ignited stationary wooden targets under ideal conditions, but failed to affect moving ships. Archimedes didn't only build the death ray, he also designed catapults, cranes, and other mechanical devices to resist the Roman invasion. Whether the death ray was fully functional or later exaggerated, it reflects the innovative and experimental mindset of Greek science. Eventually, the city of Syracuse fell to the Romans, and Archimedes was killed during the attack. As a result, his opportunity to create more inventions was lost forever. Roman concrete. Nearly 2,000 years ago, Roman engineers developed a type of concrete that still survives today. The Pantheon in Rome, the Colosseum, aqueducts, and harbors all still stand, as if time has barely touched them. While modern concrete often crumbles within a few decades, Roman concrete actually grows stronger over time. The secret of Roman concrete lies in its ingredients. They mixed lime, volcanic ash, and stones or broken bricks. When water was added, a chemical reaction began, slowly forming crystals. These crystals helped reinforce the structure. For coastal buildings, they used seawater, which sped up the crystal formation. As a result, Roman harbors became extremely resistant to waves and erosion. Amazingly, this concrete could even heal its own cracks over time, something modern concrete rarely does. The Romans built wooden formworks to shape the concrete precisely. They used a special volcanic ash called pozzolana, found only in Italy, which made the concrete last much longer. Modern research has found a rare crystal called aluminum tobormerite in Roman harbors and breakwaters. It forms under specific chemical conditions and makes the concrete even stronger. Thanks to this durable concrete, Roman architects were able to build massive domes, arches, and roofs. For example, the Dome of the Pantheon, completed in 126 CE, still stands today as the largest unreinforced concrete dome in the world. Greek fire. In the 7th century CE, the Byzantine Empire faced repeated naval attacks from Arab fleets. To protect their ships and harbors, the Byzantines developed a terrifying flame-based weapon, Greek fire. Historical records suggest it was first used around 672 CE and remained one of the most important tools in Byzantine naval warfare for centuries. This fiery weapon was deployed through siphons mounted on ships as well as handheld devices. It allowed soldiers to launch flames directly onto enemy vessels. Eyewitnesses wrote that enemy ships were engulfed in flames that couldn't be extinguished with water alone. This shows just how destructive and unique the weapon truly was. Byzantine engineers developed special delivery systems to make Greek fire more effective. Liquid fire could be forcefully projected through siphons, and grenade-like jars were used for close-range combat. Despite centuries of attempts, modern scientists have still not been able to recreate its exact formula, adding to the mystery that surrounds Greek fire. Hero of Alexandria's steam engine. In the 1st century CE, there was a famous mathematician and engineer in the Egyptian city of Alexandria, Hero of Alexandria. He created a device that could generate rotation using the power of steam. This device was called the aeolipile, and it is considered one of the earliest examples of a steam engine in history. The aeolipile looked like a round vessel placed over a flame. Inside the vessel was pipes attached to the sphere. The pressure from the escaping steam caused the vessel to spin. In this way, heat energy was converted into rotational energy. Hero didn't build this device for industrial use. It was meant for educational demonstrations or as an automatic temple device. But the aeolipile shows that Hero had a deep understanding of heat, motion, and rotational mechanics. The main parts of the device were a boiler where the water was heated, a hollow spherical vessel, 2 bent pipes through which the steam escaped. When the water started boiling, pressure built up inside the vessel. That pressure pushed the steam out through the pipes, and the force of the steam made the vessel spin. This was truly pre-modern scientific experimentation. Antikythera Mechanism. In 1901, a group of Greek sponge divers discovered the remains of a shipwreck beneath the sea near the island of Antikythera. Inside the wreckage, they found a corroded bronze object that initially appeared to be nothing more than a cluster of gears and metal plates. But later research revealed that it was an ancient mechanical calculating device, now known as the Antikythera Mechanism. This device was built around 100 BCE. It contained more than 30 intricate bronze gears arranged within a compact frame. Analysis showed that it could calculate the positions of the sun and moon, the timing of eclipses, and even the dates of ancient Olympic Games. Researchers have reconstructed models of the mechanism to understand how it worked. It featured rotating dials connected to the gears. These dials translated the regular movements of celestial bodies into mechanical motion. Its design and precision were so advanced that similar clock-like devices didn't appear in Europe again until the 14th century. Even after so many centuries, no other device from that era has been found that matches the capabilities of the Antikythera Mechanism. Its construction combined practical engineering skill with theoretical knowledge, blending astronomical observation with mechanical design. The mechanism was housed in a wooden frame, which held the gears and dials in proper alignment, allowing it to function as a portable astronomical calculator. Sushruta's surgical innovations. Around 600 BCE, in a region that is now part of India, a physician named Sushruta wrote a comprehensive medical text called the Sushruta Samhita. In this book, he described in detail the methods of performing surgeries, the instruments used, and various medical procedures. Many consider him the father of surgery. The Sushruta Samhita includes descriptions of more than 120 surgical instruments, such as scalpels, forceps, needles, and more. Each tool was designed for a specific purpose. Sushruta carefully outlined the steps for each operation, emphasizing cleanliness, precision, and careful observation. He also wrote about methods to reduce pain using herbal medicines, which we now refer to as anesthesia. Sushruta understood the importance of postoperative care, showing the depth of his medical knowledge. Testing, Sushruta didn't just write theories, his techniques were practically applied. Historical records show that medical students first practiced on fruits, vegetables, and animal bodies before operating on humans. This experimental training method helped reduce errors and improve surgical skills. One of Sushruta's most famous contributions was in plastic surgery, especially rhinoplasty, the reconstruction of the nose. At that time, facial mutilation was a form of punishment, so repairing the nose using skin flaps required both high surgical skill and deep anatomical understanding. Gunpowder accidents. Many years ago, during China's Tang Dynasty, some scientists and alchemists were searching for a potion to achieve immortality. They experimented by mixing different substances. One day, they combined sulfur, charcoal, and saltpeter. Suddenly, the mixture ignited and exploded. This was how gunpowder was born. In their laboratories, fires would sometimes break out or small explosions would occur. Some people even got injured. But from these accidents, they learned important lessons: how the mixture worked, how much was needed, and how it could be ignited. Using this gunpowder, they could shoot fire through bamboo tubes. This led to the invention of fire lances and flaming arrows, which became new weapons for warfare. This discovery helped Chinese soldiers defend fortresses, boats, and city walls.